Hello everyone and welcome back to a brand new video. And in this video I will be covering problem D, that is letter picking from Edu round 135. And I already made a video on problem C, so if you guys haven't seen it yet, do check it out. And let's start with problem D and this one. So let me go from the drawing pad. So in the problem we have been given a string of size n where n is up to 2000 and n is also even, and let's call the string s. So we have s1, s2, s3, so on up to sn minus 1 sn. There are also two people, Alice and Bob, who are playing a game. Both of them have a string of size n by 2. Initially it is empty, so both of them have an empty string of size n by 2. So Alice will move first, and she can pick either the first index. She can either pick the first index from string s, or she can either pick the last index from string s, remove it from s, and add it to her own string. So let's say name of Alice string is a, and name of Bob string is b. So she can either pick the first letter from string s, or she can either pick the last letter from string s and add it to string a. So let's say she removes sn and adds it to her own string. So she will add sn. Similarly, now Bob has to move. So Bob will do the same thing. He can either pick s1 or he can either pick sn minus 1 and add it to his own string. So let's say he picks s1. So he will remove s1 and add it to his own string. Similarly, now Alice will do the same thing again. She will either pick s2 or she will either pick sn minus 1 and she will add it to her own string. Right? So let's say she picks s2. So they will keep doing the same thing until string s becomes empty. So they will keep doing the same thing until string s becomes empty, right? And in the end, both string a and b will be filled. And after both of them are filled, we have to tell which of them is smaller, right? If a is lexicographically smaller, if a is lexicographically smaller than b, then it means that Alice wins. Otherwise, if b is smaller than a, then it means that Bob wins. Otherwise, it's a draw. So that is the problem. So given a string s, we have to tell if both of them, Alice and Bob, if both of them play optimally, who will win in the end? So basically we have to find a winner given some string s. So given s, find the winner. That is the problem in a nutshell. So let's move on to the solution. So the two things that helped me see the solution were these two things. So the first thing was the constraints, right? As you can see that n is up to 2000. So I can use a O of n square algorithm here, right? I can use a O of n square algorithm. And O of n square generally means that I will be able to iterate over all the subarrays, and I will be able to store the information of all the subarrays, right? So I will be able to store information about all subarrays because there are only n square subarrays. So if I am able to do something in O of n square, I will be able to store information about all the subarrays. So that gave me a hint that I can keep a 2D array of, let's say, kind dpij, and I can store some kind of information about all the subarrays. I don't know what I will store in dp of ij, but I know that I can keep a 2D array, right? So that was the first hint. And the second hint was that I was able to break the bigger problem into a smaller problem. How so? So for this, you need to see that there are only 4 possible move combinations. How so? So if you have string s1, s2, s3, so on up to sn, then Alice can either pick s1 or sn. So if Alice picks s1, Bob can pick s2, and Bob can also pick sn. Similarly, if Alice picks sn, Bob can either pick s1 or he can either pick sn minus 1. right? So as you can see, there are only 4 possible move combinations. This is case 1, case 2, case 3 and case 4. So I can take any of these cases and I will try to show that you can break the bigger problem into a smaller problem. So let's say I will take example of case 1 and I will try to show you the same thing. So I have S1, S2, S3, S4, so on up to Sn, right? So first Alice will pick S1 and Bob will pick S2, right? Because we have case 1. So you will have something like this. You will have string A with S1 at the end. You will have string B with S2 at the end, right? So let's say the leftover string is A dash and the leftover string is B dash, right? So overall you want to find that if A is smaller or if B is smaller, right? So basically you want to find the relation between A and B. And as we already know S1 and S2, if we can somehow find the relation between A dash and B dash, then we can use the relation between A dash and B dash to find the relation between A and B, right? And that is what we want to do, right? We want to find the relation between A and B. So if we can somehow find the relation between A dash and B dash, that will solve our problem. So what is the relation between A dash and B dash? That is basically the answer for your substring S3 to Sn, right? So you can, for the time being, ignore S1 and ignore S2 and think of string S3 to Sn as a whole new string. We can call this a string S dash of size n-2, right? We can say that string from S3 to Sn is a new string S dash of size n-2. So if we can answer for S dash, then we can answer for S, right? So basically you are breaking your initial string S into a smaller string S dash, and if you can find the answer for S dash, then you can use that answer to find the answer for string S. So if we have a new string S dash, that is basically S3, S4, so on up to Sn, you can use the answer for S dash to find the answer for S, right? So that is how you are able to like break the bigger problem into a smaller problem. So that is where the DP will also come in, right? Because if you want to like break the bigger array into smaller arrays, we can like store information. We can store answer of every subarray in a 2D array, that is DP of ij. So that is where DP will come in, right? So I will store answer of S dash in my DP array, right? Because it is starting from index 3 and ending at index n. So I will say my DP of 3, n is equal to answer of S dash, right? And I will use this to find answer of S, which is basically DP of 1, n. So that is how I will break the bigger problem into a smaller problem. So now let's try to use DP of 3n to find the answer for DP 1n. So now let's do some casework. So I will define, first of all, let's define my DP of ij. So I will define my DP of ij as winner of subarray si plus 1, so on up to sj, right? And my DP of ij will be equal to 0 if Alice wins. It will be equal to 1 if it's a draw, and it will be equal to 2 if Bob wins, right? Obviously Alice will want to minimize the value, right? Alice will want to minimize the value of DPij, right? Because if the value is 0, Alice will win. So Alice will always try to minimize the value of DPij. Similarly, Bob will always try to maximize the value of DPij, right? Because if Bob wants to win, he will have to reach the value of 2. So Bob will always try to maximize the value of DPij. That is the reason I have kept my draw in the middle, right? You can also like shuffle the values, but it will not help us with the implementation, right? So to make the implementation a bit easier, I have kept draw in the middle, Alice as the minimum element and Bob as the maximum element. So now I'll use DP of 3n to solve for DP of 1n. So we have two arrays. This is A dash, this is B dash. So this is basically the answer for DP of 3n. We have S1 here, we have S2 here, and we want to find the answer for A and B. So obviously if my A dash is smaller than B dash, or you can say that my Alice wins, or you can also say that my dp of 3n is equal to 0, right? Then you can say that my dp of 1n is also 0, right? Because if Alice is winning, that is if A dash is smaller than B dash, we don't need to think about value of S1 and S2, right? Because if the prefix is smaller than if prefix of A dash is smaller than prefix of B dash, then we don't need to think about S1 and S2, right? So in this case, Alice wins. If dp of 3n is equal to 0, then dp of 1 comma n is also equal to 0. You can use the same logic to say that if Bob wins, that is if dp of 3n is equal to 2, then it means that dp of 1 comma n is also equal to 2, right? Using the same logic. And if it's a draw, that is dp of 3 comma n is equal to 1. Now if A dash is equal to B dash, now we have to think about values of S1 and S2, right? So now if A dash is equal to B dash, now we have to think about values of S1 and S2. So we will compare S1 and S2. So if S1 is less than S2, then obviously Alice will win. So my dp of 1 comma n will be equal to 0. If S1 is equal to S2, then it will be a draw. So dp of 1 comma n will be equal to 1. So if my S1 is more than S2, then Bob will win. So dp of 1 comma n is equal to 2, right? So these are the 3 cases when it's a draw. So that is how we can solve case 1. You can do the same casework for all the cases, and we can make the transitions for all the dp states, and that will help us solve the problem. So that is the entire solution if you guys want to code it on yourself, but I will still go forward and like give you a hint for all the caseworks. So let's summarize the solution. So let's summarize and like do maybe a bit of casework. So as you know that Alice wants to minimize the score, right? Alice wants to minimize the score, and Alice has 2 choices. Either she can pick the, like if we have subarray si plus 1 so on up to sj, right? That is if we want to find dp of ij. Alice wants to minimize the value of dp ij, right? So she has 2 choices. Either she will pick the first index, that is si, or she will pick the last index, that is sj, right? So she will we can break this into 2 parts. When Alice picks the first index, that is when Alice, I can call this answer for start, and I will call this sj. When Alice picks the last index, I can call this answer end, right? For the starting index and for the ending index, right? So in this case, when like Alice picks si, Bob has 2 choices. Either he can pick si plus 1, or either he can pick s of j, right? And as Bob wants to maximize the answer, he will try to find the move which will maximize the answer, right? So if you pick si, Bob will pick the value si plus 1 or sj, whichever will maximize the answer, right? So he will try to maximize answer start. So if Alice picks si, Bob will pick either si plus 1 or either sj, depending on whichever maximizes the answer start. Similarly, if you pick sj, Bob can either pick sj minus 1 or Bob can either pick si, and he will again try to maximize your answer end. He will again try to maximize your answer end, right? So now you know that what are the worst values for your answer start and for your answer end, right? So now you know that if you pick si, what will Bob pick to maximize answer start? And now if you pick sj, you know that what will Bob pick to maximize your answer end. And obviously if you are Alice, you want to minimize the answer, so you will pick the minimum value among both of them. So you will pick minimum of answer start and answer end, right? And that will be your dp of ij. So let's do some casework now, right? So we can break it into 2 parts where Alice picks si. So in this case, Bob has 2 choices. Either Bob can pick sj, right? So if Bob picks Sj, my answer of start will depend on which value? It will depend on dp of I plus 1 and j minus 1. Right, so if Alice wins, that is dp of I plus 1 j minus 1 is equal to 0. That means that answer start will also be equal to 0. Right, so you have to find the maximum, right? As Bob will try to maximize the answer, so we can keep a maximum value here. We can say that answer of start is equal to maximum of answer start and 0, right? Similarly, if Bob wins in dp of I plus 1 j minus 1, if Bob wins, then I can say that my answer of start is equal to maximum of answer start, comma 2. And if it's a draw, then like we can see the values of Si and Sj and compare the answer on the basis of that. Similarly, this is for when like Alice picks Si and Bob picks Sj. Bob can also pick Si plus 1. In that case, my answer start will depend on, which value? It will depend on dp of I plus 2 and j, right? So we will find the maximum value of answer start that we will get from both of these cases, and we will like keep that answer start value. Similarly, you can do the same thing for answer end. And in the end, your dp of ij will be equal to minimum of answer start and answer end, right? Because you want to minimize the answer, because Alice wants to win, so she will pick the answer that will help her minimize the dpij value, right? So she will either pick answer start or answer end, whichever will minimize the dpij value. And in the end, you can just print your answer. If your dp of 1 comma n is equal to 0, Alice wins. If it's 1, it's a draw, and if it's 2, Bob wins. And that is the entire solution. So if you guys have a doubt, feel free to join my Discord server. I will be more than happy to answer your doubts there. And for the time being, you can look at my code. You can also like see my submission at Codeforces to see my code. And here's the code. So here's my recursive function. So 0 means Alice wins, 1 means it's a draw, 2 means Bob wins. So if I is more than j, just like say that it's a draw. Otherwise, if dp of ij, if I already know the value of dpij, like just pass that value. And my answer start is equal to -1, answer end is equal to like 0. You can also do -1 here, it does not matter. Then these are the 4 cases, right? This is my first case when like I will take Si and Si plus 1, right? So I will find the value of answer start here. Similarly, this is my second case when I will take Si and Sj, and I will again find the value of answer start here. Similarly, I have the third case where I will try to find the value of answer end. Here I pick Sj and Sj minus 1. And then I have the fourth case where I will pick Sj and then I will pick Si, right? So I will find the value of answer start and answer end from all of these cases. And in the end, my dp of ij will be equal to minimum of answer start and answer end, and I will then I can just return dp of ij. And here's my main function. So in the main function, I have a dp, a 2D dp, and I have a string answer that is like at 0 Alice wins, at 1 it's a draw, and 2 it Bob wins. So I can just print. I will just like call the recursive function, and it will give me a value of 0, 1, and 2, and I can just print the answer on basis of that, right? So that is the entire solution. And if you guys have a doubt, like I said previously, you can join my Discord server, and I will see you guys in the next one. Bye bye. Also, if you guys don't know, Continue Newton School is offering a full stack development course. The course is over 6 months long, and it is totally based on pay after placement model, and you don't have to pay anything. There is 0 hidden fees, there is 0 upfront fees, and they are granting you a minimum package of rupees 5 lakhs. and the average package is rupees 7 lakhs and the highest package is over rupees 26 lakhs. So it is a very great opportunity. Also, all their mentors are from top MNCs like Google, Flipkart, Zomato, etc. Also, they will get you placed into the top MNCs as well, like Google, Flipkart, Zomato. You can learn from the mentors that are working at those companies, and you can land a job at those companies yourselves. Also, you don't need to worry if you guys think कि यार मेरे को भी कोडिंग आती नहीं है, मैं भी फ्रेशर, मेरे को बिल्कुल नहीं आता है. The course is over 6 months long and they will teach you from scratch. So you can still sign up for this. And if you guys are looking for a career in the tech field, this is a very great head start that you should sign up for. And if you want to land a job, I highly vouch for this. And if you guys want to sign up, there will be a link down below and you can go and sign up from there. So yeah, be sure to sign up for this, and I will see you in the next video. Bye bye.